This video will be practice problems on the first derivative test, finding out when a function increases or decreases based on its first derivative. Okay, so problem number one, draw a function b of x that has a relative min at x is -3 when b prime of -3 does not exist. This is a follow along type of video, so please try this problem first on your own, pause the video and work it out. And then pause it to see what the solution is. And if you got totally lost, you can see how I thought through the problem. Okay, so the quote unquote intimidating part is probably b prime of -3 doesn't exist. Okay, so what are the different cases a derivative does not exist? If it's not continuous there, but it's saying that there's a relative min there, so it seems like it's continuous there. So that's probably not that. What else? If there's a vertical tangent there, if it's a vertical tangent, it wouldn't be a relative min because it'll be infinitely increasing or infinitely decreasing. So it wouldn't be a min there, a relative min there. So what's the last case? It's if there's like a sharp turn or a corner. So do we know a function that has a sharp turn or a corner? The absolute value function. And yes, the absolute value function has a relative min at the turning point. So we can just say this is the absolute value of x plus 3 and be done with it, this function. Okay, so here was not so much about increase, decreasing and all that, but we had to know the different cases for when the derivative does not exist. Okay, 2a. Give the x values at which this function y has relative extrema and classify those extrema. Go ahead and do this one first on your own. Okay, so we probably want to take the derivative to see if the derivative changes sign, then there's a max or min at the original function. Okay, if the derivative goes from positive to negative, that means the function increased then decreased, which means there's a relative max. And if the derivative went from negative to positive, that means the function decreased then increased, which means there is a relative minimum there. Okay, we're going to use that concept to help us answer this. So we need to go through the motions of taking the derivative. Y prime is we need the quotient rule, so I'm not going to go over that step. You can check this on your own. Okay, we need to find what we call the critical points. Okay, critical points are when y prime, the first derivative, is 0 and or when the first derivative, y prime, is undefined. So we need to get all those points. Okay, so let's first do when y prime is 0. Okay, so we set this equal to 0. So all we care about is if the top is 0, because if you multiply x plus 3 squared on both sides, 0 times x plus 3 squared is just 0, right? So we only care about when the top is 0. Okay, so if we expand this out and simplify it, it'll be this polynomial here, this quadratic here, which means the quadratic formula. So x is plus or minus 2, 5. Okay, those are two critical points. And as I was saying, the critical points also occur when y prime is undefined. When is it undefined? It's when we divide by 0. So we're dividing by 0 when x is -3. So x is -3 is also a critical point. Okay, we're going to take these 3 points. We're going to do the sign test now. So to do it quickly, how I usually recommend it is just draw a number line with the critical points, put some tick marks. All right. And now we're going to check the sign on each interval. We're going to plug in a point in this interval into our y prime, see if y prime is positive or negative, and we write the sign there. Okay. So for example, we can plug in the extreme points like -1,000. Okay. So if we plug in -1,000, we would get that this is negative. This would be -2 negative, negative, positive, right? Positive minus. This would be, well, the bottom's always positive. Okay, so we don't even need to look at that. I'm just thinking out loud right now. So if we plug in negative 1,000 over here, it won't be as big as this guy over here. So if you are able to do the extreme numbers, it's usually easier. If not, then you can plug in like x is negative 10, x is negative um, 4, something like that. All right. If you're allowed to calculate it, even better. You don't have to do it in your head. But usually, if the numbers are nicer, um, you should plug in an extreme number, or the function's nicer, you should plug in an extreme number to quickly see if it's positive or negative. So it should be positive, and then you repeat the steps on each interval. So in this interval, you might want to click 0. In this interval, you pick another number. And in this interval, you pick another number to do the sign test. Okay, so you should get this. So we are looking at when the derivative changes sign. That's right here, went from positive to negative. Did not change sign here, but it also changed sign here. So there's a relative max at x is, sorry, yeah, max at x is minus 3 because the derivative changed from positive to negative. And there's a relative min at this point, 3 plus 2 root 5, because the derivative went from negative to positive. Okay? So this is where the relative max min occur. This question specifically asks to give the x value. So I'm just going to say it now. If it asks for just find the relative max and minimum values, it didn't just say locate where they occur or like give the x values. It didn't say that. It said what are the relative max minimum values. It's asking for the y values. So you got to actually find the points. Okay, so you don't get tricked on the multiple choice if they ask you something like that. Okay, you got to answer the question. All right, 2b. Give the x values at which y equals this guy has relative extrema and classify those extremas. So go ahead and try this one. We take the derivative of y. Y prime is, we need the quotient rule, so go through this yourself. I'm going to just jump to here. This is what I get for y prime. So critical points occur when the top is 0 and when the bottom is 0 as well. So we get that x is 0 and 1. I'm not going to go through all the algebra. I'm going to assume you know that, all right? So for both the top and bottom, we find x is 0 and 1. So our critical points are just 0 and 1. Actually, we notice that the domain of this function, y, is x is greater than 0, because natural log, it needs to be, in itself, needs to be x is greater than 0. That's the domain. So we can discard x is 0 as a critical point, actually. So we only have one critical point. X is 1. Okay, we do the sign test. So we draw the number line, draw it with the critical points, but since I still chose to draw 0 because of the domain restriction. Okay, so it will help us out in, we can't plug in x is like negative something. It just doesn't work. Okay, so from 0 to 1, we can plug in like half. We would get that y prime is negative. From 1 onward, we can plug in any number. Like you can plug in 2, you can plug in 1.5, you can plug in 1,000, 10,000, anything. You would get that y prime as positive. So does the derivative change sign from negative to positive? What does that mean? That means y has a minimum there. Okay. Problem 3. Given the graph of m prime, describe and classify the relative extrema of m. Okay. How do we think about this? Relative extrema occur when m prime changes sign. So it changed sign over here from negative to positive, right? That means m has a relative min there at, what is this? Let's say it's minus 0.9, okay? The derivative only changes sign again right here. This is 0, but the derivative didn't change sign. It didn't cross the x-axis. So there's no relative min-max there. Over here, it changes sign from positive to negative, so there is a relative max there. M has a relative max there at, what is that? 1, 2, 3, 4, 5, 6, 7. X is equal to 7. That's what I say over here. Okay? Which is G and which is G prime. Okay? So usually how I pick these up is I match when there's a max min for one of them is the derivative 0 there. For example, there should be a 0. If this is G and this is G prime, there should be a 0 for G prime. Looks like there is, right? Looks like there is, looks like there is, and looks like there is. So it looks like this upper one is probably G, and this lower one is probably G prime. And we can also check that the function is always increasing up to here. Derivative is always positive up to there. Function is decreasing here, derivative is negative. So that looks like it. Okay. 5a, find all points of discontinuity. So how does this relate to first derivative test and all that? So go ahead and try this first on your own. It might be part B that is related to that, but okay. We want to find out if f is discontinuous anywhere. First, we have to realize that sine x and cosine x individually are continuous for all real x, okay? Same for sine squared, because it's just sine x quantity squared, okay? So we just got to check at the switching points at x's pi. So we got to use the definition of continuity, okay? So limit as x approaches pi from the left, that's this branch, it's 0. Pi from the right, that's this branch, that's also 0. Since the two one-sided limits are the same, the two-sided limit is 0. And what is f of pi? It is 0. It's equal on this branch. So that means f is continuous everywhere, and there's no discontinuities. Okay? How about if f prime of pi exists? You got to remember, a derivative is a limit. Remember the limit definition of the derivative? Limit as h approaches 0, f of x plus h minus f of x all over h. It's a limit. So the derivative needs to be the same from both sides as well. Okay? And the prerequisite for differentiability is continuity. So in part A, we found it was continuous, so that condition is met. I recall there's a trick problem on one of the BC multiple choice tests, one of the years on the release exams, in that the derivative from both sides matched, but it was not continuous. So a lot of people got tricked by that. So you got to remember, prerequisite for differentiability is continuity, which we already found in part A. It's continuous. So now let's check if it's differentiable. Okay. So if we differentiate from the left, we approach from the left. That's this branch. What's the derivative of sine x times cosine x? We would need the product rule. Okay. So you evaluate it, it's 1. Here we need the chain rule. If we take the derivative from the right, okay, it's 0. The two limits, remember, derivative is a limit. The limits don't match, so the two-sided derivative does not exist. Okay, on what intervals is f increasing? What would be r if it's plural, but that's fine. Okay. So we do the derivative, okay? We got to go piece by piece. And remember, it's not differentiable at pi. So we would pick that as a critical point as well, okay? But we're actually interested in just 0 to 2 pi. Okay, so all right, so let's go by piece 1 first. So this is the derivative that we found from before. We set it equal to 0. Okay, so we can rewrite this with the trig identity. Cosine of 2x is 0. Hopefully, if you know this trig identity, it simplifies it a lot. Feels like you need to know it, it seems like, according to this test prep book. So x is pi over 4 and x is 3 pi over 4. Let's do the sign test. That's right here. Okay, I'm not going to go through all that, but here is the result. So that means on piece 1, f is increasing on 0 to pi over 4 and 3 pi over 4 to pi. Not in this interval because it's decreasing. The derivative is negative. Okay, now let's go to the other piece. Take the derivative, set it equal to 0. We can use another trig identity. This is just sine 2x, which helps us out a lot. So then x is pi, 3 pi over 2, 2 pi. Those are our critical points. We do the sign test. So it's, whoops. Here's lagging, my bad. So this is what the result of the sign test is. Where's the derivative positive? From pi to 3 pi over 2. So it's only increasing in this interval. So now we got to combine our two findings from piece 1 and piece 2. You got to be careful though. Okay, so f increases on 0 to pi over 4, which we found in piece 1. 3 pi over 4 to pi, which is from piece 1, and now union with this piece, pi to 3 pi over 2. So don't make this mistake that, oh, it's from 3 pi over 4 to pi, and then from pi to 3 pi over 2. Don't combine these two into 3 pi over 4 to 3 pi over 2. We can't do that because, remember, the derivative does not exist at pi from part B. So it's actually not increasing nor decreasing there. Okay? So that's why we got to split it up like this. No combining them. Okay, this is a technicality, but if it's multiple choice and they give you this, don't pick that. All right. Okay, that's it for this video. Hopefully it was helpful and some good practice for you. Please give this video a like if it has helped you in any way, and hopefully I'll see you in another video as well. Bye.